Hello, welcome once again to my channel. How are you? Today we'll be going through absolute value graphs. Absolute value graphs. What is an absolute value? Please remember that when you have a value inside an absolute value bar, it means that whatever value you have there must always return a positive value. So even if I have negative 2 here, it returns a positive 2. So bearing that in mind, we know that we can have anything in my absolute value bar. Whatever I have, whether it is a positive or a negative, having in mind that it will still return a positive, we have to consider the two options. So let's go through this question. It says, sketch the graph of y equals to absolute bar of 2 minus x plus 3x plus 2 and y equals to absolute bar of x squared minus 4 on the same set of axes. Now, let's start simplifying each of the expressions. This will give us a linear function and this will give us a parabolic function. But the restrictions are what differentiates our absolute value graph from any other type of graph. Now, let's look at this. If we have y equals to this plus 3x plus 2, the whole job is done on the absolute value. So remember what I said previously, we can only return a positive or a negative. Irrespective of what is inside, it returns a positive. So we consider the option of having both positive value or positive expression and negative expression in the absolute value graph. So when we have negative positive expression, it means that whatever that is in that absolute bar will be a positive greater than or equals to 0. Or second condition, we can also have whatever that is in that bar being a negative. Less than 0 means a negative. So this is what we simplify and also use it to simplify our expression and understand the conditions for which our graph will travel. Now, if it is positive, then this expression becomes 2 minus x plus 3x plus 2. So when we simplify this, 2 plus 2 is 4, and negative x plus 3x is 2x. This is the graph we are going to sketch for the positive. Let's fully simplify this. If we simplify this, x will be less than or equals to 2. That is the condition that we'll be working around when we are sketching our graph. That is the condition that satisfies this expression when the value in the absolute bar is positive. Let's look at the negative option. The negative option, the value that satisfies it, if we simplify this, we have x is greater than 2. This condition will satisfy this when the value in the absolute bar is a negative. Remember, the value in the absolute bar can be a positive or a negative. So this is our restriction when we have a positive value, and this is our restriction when we have a negative value. Let's look at the expression when we have a negative value. This becomes, everything in that absolute bar becomes negative. Plus 3x plus 2. So in simplifying this, we'll have negative 2 plus x plus 3x plus 2. So finally, the graph, there this negative 2 cancels out 2, the graph will be the graph of 4x. So we are going to sketch the graph of 4x with this restriction and sketch the graph of 2x plus 4 with this restriction on the same set of axes. So this is what differentiates the absolute value graph from other graphs. Luckily, these are just linear functions, so we only need our x and y intercept for each. Here our y-intercept, remember mx plus c or mx plus q. This serves as our y-intercept. So I will go in first to make it easy. So here I'll go in twos. That's my x-intercepts. And please do not mind my scale. If you are provided with a grid line, then the graph will be perfect. But let's get the concept here. So my y-intercept here is 4, first graph, and then my x-intercept, if I make y 0, I will have negative 4 here, x becomes negative 2. X becomes negative 2, so my x-intercept will be negative 2 and 0, my y-intercept is 0 and 4. So we go to negative 2 and 0, and we can sketch our linear graph. This is our linear graph. Less than or equals to 2. So it means this is 2. It means that the value of x cannot go off here. So wherever we have that, we have to take it off. So anything greater than 2 must go off from that graph. Now let's look at the other graph. We have y equals to 4x. X and y intercept for this will be 0. But we need to get the slope of the graph. So let's take one more point. If x is equals to 2, y will be equals to 4. So if x is equals to 2, 4 times 2, y will be equals to 8. So we can get 2 and 8, and we have 0. And 0 as our intercept. So we can have this graph. Okay, let's make it a little bit straight. Sorry about this. So this will be our graph. This will be my graph. Now, this is my linear graph. If this is my linear graph, remember this passes from the origin. The restriction must also be respected. We say that x is greater than 0. X is greater than 2. So it means anything less than 2 on the graph must be wiped off. Absolute value graph depends and feeds on these restrictions. So this will only be my graph. So what we have here, where the two graphs meet, is what we call a salient point. More like the point of intersection, but because there are restrictions, the other part is gone, the other part is gone, we refer to it as the salient point. So that is our graph for this first function. Let's see what we can do for the second function also, which is a parabolic function. Now for the parabolic function, the same approach. You have y equals to absolute value of x squared minus 4. Like I said, this can be positive, greater than or equals to 0, or it can also be negative, less than 0. So we solve for x. Here we will have x is, x squared is, x is, okay, let's factorize. If we have this is dot, x minus 2 and x plus 2 is greater than or equals to 0. Using critical values, we will check. X is greater than 2 or x is greater than or equals to negative 2. Let's check for critical values. Greater than 2, if we take a 3 squared minus 4, that's 9 minus 4 is 5, this is valid. Greater than or equals to negative 2, let's choose negative 1. Negative 1 all squared is 1 minus 4. 1 minus 4 is minus 3, is not valid. So using the critical value, we change this to less than and equals to. So these are the two conditions that will make this expression to be valid. So for this graph, these are the two conditions for the positive graph of x squared minus 4 in absolute value. Now let's look at the negative. So remember, the function here is x squared minus 4 because it is positive. Now let's look at the negative. The same approach. We factorize using dots. X minus 2, x plus 2 is less than or equals to 0. X is less than 2, x is less than negative 2. Let's check for critical values. X is less than 2. If we use 1, 1 squared is 1 minus 4 is minus 3. Is it less than 0? Valid. X is less than negative 2. Negative 3 all squared is 9. 9 minus 4 is 5. Is it less than 0? No. So we change this to x greater than negative 2. So in this case as well, we are looking at these two conditions to satisfy this expression when the value of the expression inside the absolute bar is a negative. And the function we have here will be negative of x squared minus 4. So the graph we are going to sketch will be the graph of negative x squared plus 4. So we are going to sketch these two graphs, one representing the positive value inside the absolute bar and one representing the negative value inside the absolute bar, and we will use these restrictions to place them where they should be. Now let's look at the first one. X squared minus 4, we have our intercept at 2 and negative 2. So our intercept will be at 2 and negative 2. Then our y-intercept will serve as our turning point because we don't have any b. So our turning point is negative 4. So in that case, we will have this graph. Now remember, our condition says that x cannot be greater than 2. X is greater than or equal to 2. That's number one. So only this part of x is valid, greater than or equals to 2, and less than or equals to negative 2. Less than. So this other part will go away from the graph. Because x, the graph says that it can only be greater than or equals to 2 or less than or equals to 2. So we only have these two parts. The curved part of that graph must be wiped away to fulfill the restriction given for absolute bar. Now, let's look at the second graph. For the second graph, we have negative x squared plus 4. Plus 4 will also serve as our turning point as well as our y-intercept because there is no b. Now, we have to check for our x and y-intercept. We have our y-intercept, x-intercept, make y 0. So, if we make y 0, we will have negative x squared plus 4. And if you look at this, we'll still have our plus or minus 2 as our x-intercept. So, we have negative 2 and 0 and 2 and 0 still. Negative 2 and 0 and 2 and 0. Now, let's sketch those. We have the same intercept. Now let's sketch the graph. We have 4 instead of negative 4 that we had previously. So this graph is going to give us a graph from here to here and from here to here. So this will be our graph. Now we look at the restriction again. The restriction here says that x must be a value less than 2. A value less than 2, this has already crossed 2. So we have to erase this part of the graph. And also x must be a value greater than negative 2. These are less than negative 2, so we also have to erase this part. So from this parabolic function, we only have this graph left. So we see now we have this graph left. And for parabolic functions, we have two salient points. So we have two salient points. So this is how to sketch graphs of absolute value. Remember, the idea is that it must, whatever you have in your absolute bar, must return both a positive and a negative. And then you use the restrictions to check which one applies. And you also use your restrictions to generate your equation. And that is what we generate as a graph. Remember, if you do not erase the part that doesn't apply, that means you didn't apply the restrictions, then it is not going to be an absolute bar graph. It's not going to be an absolute value graph, and then you must have done something wrong. Please, that is just the difference between this and when we are dealing with ordinary, parabolic, linear, exponential graphs, and the rest of them. Please continue to study, continue to follow my page, continue to subscribe to my channels. When we come back next week, I'll give you the videos of absolute value graphs involving exponential and hyperbolic function. Enjoy the rest of your day.